Hi, my name is Jacoby Melton, and welcome to my Physics 2211 Lab 4 presentation. The purpose of this lab was to observe and measure the motion of a spring mass system that moves in 2 dimensions while oscillating on a spring. The observations will be compared to a computational model, and the changes in energy will be measured using this computational model. The results of this lab showed that the predicted model in the computational model closely replicates the observed motion, and that the total energy in the system remains zero, which satisfies the energy principle. The fundamental physics principles in this lab are Newton's second law and the energy principle. Newton's second law says that the net force is the sum of the spring force and the gravity force in this case, or more generally, the net force is the change in momentum over the change in time. And from Newton's second law, we also get the velocity and position update formulas, which are used in the computational model. The energy principle is that the change in the energy of the system is equal to the change in the kinetic energy plus the change in the gravitational potential energy and the change in the spring potential energy. The formulas for the change in kinetic energy is 1/2 mass times the change in velocity squared. Change in gravitational potential energy is mass times gravity times the change in the y positions, the y-axis squared, or not squared, just the change in y. And the change in the spring potential energy is 1/2 times the spring constant times the change in the spring length squared. In the experiment, the system was the mass, the spring, and the earth. The initial conditions are that the mass on the spring is 0.402 kilograms. The initial position is negative on the x and y axes and 0 on the z-axis. I have the spring constant here, gravity is 9.8, and the initial velocity is 0. This is a screenshot from my tracker software after I put in the points and got the data shown on the right. I put my initial conditions and the constants into the computational model, and then I used these to get the kinetic energy, potential energy, gravitational potential energy, and spring potential energy for the initial values and the total energy as well. Inside the while loop, to get the changes in energy, I calculated the net force by adding together the spring and gravitational force, and then I used the position and velocity update formulas to get the current velocity and position of the ball. I then used the energy principle to find the formulas to find the change in kinetic energy, gravitational potential energy, and the spring potential energy, and I used the formulas that were shown a couple slides earlier. And then I used this to find the total change in energy, delta E. I added them together. On the right here is the graph of the results from the computational model. This orange line in the middle is the total change in energy, and you can see that it's about 0, which satisfies the energy principle. And then the sum of all of the delta K and both delta U's is going to equal about 0, is the orange line. Possible sources of error in this experiment were that drag force from outside forces was not accounted for, which could have changed the results. Human error could have occurred while using the tracker software, and it's possible that the spring was moving some at the beginning of the video, and the initial velocity could have been something other than 0, which was not accounted for. For the first what does it mean question, is the energy principle satisfied? Yes, it is, because delta E remains about 0, and you can see here that delta E is the sum of delta K, delta U, and delta U from gravity and delta U from the spring. For the second what does it mean, I got the average oscillation periods for the x and y positions. For the x position, it was 1.661 seconds, and the y position, it was 1.488 seconds. The difference between the two is that when the x position peaks, or when the x graph peaks, the y graph hits a low, and vice versa. You can see it here right before 2 seconds. The x is at its lowest and y is at its highest. and then right after 2 seconds, x is at its highest and y is at its lowest, and they meet about somewhere in the middle to balance out. Thank you for watching my presentation.